Hello students, in today's lecture we are going to learn about units and measurement NCERT section 1.4 1.5. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. So in today's lecture, we will cover first is 1.4 dimensions of physical quantities. Then 1.5 dimensions, formulae and dimensional equations. So these two topics we will cover in today's lecture. So our main aim to understanding the physical dimensions through fundamental quantities. We know 7 types of fundamental quantities. So using these quantities we will solve other dimensional formula of other physical quantities. So here question arises, why is it necessary? Dimensions of physical quantities, why is it necessary? The first reason is checking the consistency of equations. Second reason, deriving relations between physical quantities. It helps in deriving formulas by equating the dimensions of the involved quantities. Third, converting units. Fourth, identifying the nature of physical quantities. So this is very helpful. The nature of a physical quantity is described by its dimensions. We know two types of physical quantity, scalar quantity and vector quantities. So if we talk about the physical quantity, it is described by its dimensions. All physical quantities represented by derived units can be expressed in terms of some combination of 7 fundamental or base quantities. In previous lecture, we already learned about the 7 types of fundamental or base quantities. We shall call these base quantities as the 7 dimensions. 7 dimensions of physical world, which are denoted by square bracket. Listen carefully. Denoted with square bracket. This type of square bracket. Thus, length has the dimension, this one, square bracket open, L square bracket close. So this is the dimension of the length, dimensional formula of the length. If we talk about the mass, so the dimensional formula is m. If we talk about the time, so dimensional formula is t. Listen carefully, it is denoted with square bracket. If we talk about the dimensional formula of physical quantities, it will be denoted by or denoted with square brackets. Third is electric current. So electric current is square bracket and A. Thermodynamic temperature. So the dimensional formula is this one, K. Luminous intensity, this one, CD. And amount of substance, mole. So this is the 7 fundamental quantities and their dimensional formula. And using these dimensions, listen carefully, using these dimensions we will derive other dimensional formula, or we can say derived dimensional formulas of the physical quantities. The dimensions of a physical quantity are the powers or exponents to which the base quantities are raised to represent that quantity. In mechanics, all the physical quantities can be written in the terms of dimensions: m, mass, length and temperature. It means what? It means if we want to calculate the dimensional formula of the any physical quantities, we will use the dimensions m, l, t, mass, length and t with square bracket. This is the representation. For example, the volume occupied by an object is expressed as a product of length, breadth and height, or three lengths. It means what? It means length, breadth and height. All these three are also known as length. So hence the dimensions of the volume L into L into L with square bracket. Without square bracket it is incorrect. So L into L into L become L cube. So dimensional formula of the volume occupied by an object is expressed as this one, square bracket L cube. Clear? As the volume is independent of mass and time, it is said to possess zero dimensions in mass. It means what? It means here if we talk about the volume, so volume is independent of mass and time. We know any physical quantities can be expressed m, l and t. So here volume is independent, so it will be m0. Volume is independent of mass and time, so m0 and time is also 0. So the remaining term is L cube and three dimensions in length. So what will be the dimensional formula of the volume? m0, L cube and t0. Force as a product of mass into mass and acceleration, F is equal to ma, can be expressed as F is equal to mass into acceleration. So mass into acceleration. What is acceleration? What is the formula of the acceleration? Length divided by time square. Length divided by time square. So the dimensional formula of length is what? And dimensional formula of time is what? So the dimensional formula of length is m, L is L, and the dimensional formula of time is t. So here time square, it means t square. So three dimensions of the force, this one, mass, length divided by acceleration. So it will be ml t raised to the power minus 2. So this is the dimensional formula of the force. Clear? The dimensional formula of the force is clear? Any doubt? I think no doubt. Thus, force has one dimension in mass, one dimension in length, and two dimension in time. So dimensions in all other base quantities are 0. Dimensional formula and dimensional equations. The expression which shows how and which of the base quantities represent the dimensions of physical quantity is called the dimensional formula of the given physical quantity. For example, the dimensional formula of the volume is this one with square bracket m0 l cube t0, and that of speed or velocity is m0 l1 and t raised to the power minus 1, because velocity is what, length upon distance upon time. So the dimension formula of distance is L, and dimension formula of 1 upon t, it means t inverse. Similarly, m0 l t raised to the power minus 2 is the dimensional formula of acceleration, and m l in l raised to the power minus 3 t0, that of mass density. So this one is the dimension formula of the acceleration, and this one is the dimension formula of the mass density. An equation obtained by equating a physical quantity with its dimensional formula is called dimensional equation of physical quantity. The dimensional equation are the equations which represent dimensions of a physical quantity in terms of base quantities. It means what? It means if we talk about the dimensional formula or dimensional equation, so dimensional formula or dimensional equations are the representation of any physical quantity, or it represent the dimensions of a physical quantity from the base quantities. We know there are 7 types of base quantities. So using the base quantities, we can derive the dimensional formula of physical quantity in terms of m, l and t. For example, volume. This is the dimensional formula representation of the dimensional formula of volume. So it has 3 length. Volume has only 3 length. So 3 length means L into L into L. So L, it become L0, L cube. It become L cube. And there is an absence of mass and absence of time. It means volume is independent of mass and volume is independent of time. So the remaining term is L cube. So this is the dimensional formula of volume. Now if we talk about the velocity, so velocity is what? Distance upon time. So here velocity is independent of mass. So here m0. Distance, the dimensional formula of distance is L. And the dimensional formula of 1 by t is t inverse. So that's why dimensional formula of V become m0 L and t raised to the power minus 1. And we talk about the force. The dimensional formula of force is ml t raised to the power minus 2. And dimensional formula of rho is m L raised to the power minus 3 T0. Clear? Any doubt? This is clear. Velocity, force and rho. This is density. Rho is the density here. Rho is the density. So density is what? Rho is equal to mass upon volume. Listen carefully. Mass upon volume. Volume. So we know the dimensional formula of mass is m only. And the volume is L cube. L cube. This one. And it is independent of time. So it will be become m L raised to the power minus 3 and independent of t, so it will be T0. So this is become dimensional formula of density. Clear? And if we talk about the force, F is equal to mass into acceleration. Mass into acceleration. So what is acceleration? Acceleration is unit is meter per second square. Meter per second square. So it means the dimension formula of mass meter is what? L and divided by second square. Second square means second time. So dimension formula of time is t square here. So it will be become L and t raised to the power minus 2. So this is the dimension formula of acceleration. And if here mass. So dimension formula of mass is m only. Only one m. Because it is independent of L and t. So m and the dimension formula of A is here. We already derived. So L t raised to the power minus 2. So when we combine both, it will be m L t raised to the power minus 2. So this is the dimension formula of force. Now it is clear? Okay. And this is the velocity. I hope this is clear. More about the dimensional formula for the coefficient of viscosity we will learn in next slides. Dimensional formula is necessary because it verify the consistency of the equation, deriving relations between physical quantities, converting units, identifying the nature of the physical quantities, predicting formulas. That's why this is very important. This is the bracket is the representation of the dimension formula. Any doubt? The dimensional equation can be obtained from the equations representing the relation between the physical quantities. Let's derive some dimensional formulas of physical quantities. First is acceleration. So acceleration is velocity upon time. So here we substitute the dimensional formula of velocity and dimensional formula of time. So the dimensional formula of velocity is this one, L T inverse with square bracket, and dimensional formula of time is T. So the dimensional formula of the acceleration become L T raised to the power minus 2. Here the in denominator T power 1 and in numerator T power minus 1. So it will be become T raised to the power minus 2. So this is the dimensional formula of acceleration. Second is frequency. What is the dimensional formula of the frequency? So before deriving the dimensional formula of the physical quantity, that is frequency, here what is question arises, what is the formula of the frequency? What is the formula of the frequency? So frequency is the reciprocal of time period. Yes or no? Reciprocal of time period. It means F is equal to frequency is equal to 1 upon T. 1 upon T. So the dimensional formula of T is T, only T. So frequency is what? So here we put the dimensional formula of T. So it will be 1 upon T, it means T inverse. So T inverse is the dimensional formula of frequency. Next physical quantity is work. So how we can derive the dimensional formula of work? So first of all, here question arises, what is the formula of the work? So force into distance, or we can say force into displacement. So now here substitute the value of dimensional formula of force and the dimensional formula of distance, and we will get the dimensional formula of the work. Clear? So the dimensional formula of force is this one, ml T raised to the power minus 2, and the dimension formula of distance is L, only L. So L is the dimension formula of distance. So force dimension formula is this one, distance dimensional formula is this one. So after multiplying, it will be m L square, because here L into L. So L square and T raised to the power minus 2. So it will be become dimensional formula of the work from the formula work force into distance. Next is momentum. Same question. To derive the dimensional formula of the physical quantity, first of all, here question arises, what is the formula of momentum? Formula is mass into velocity. So mass into velocity. Now dimensional formula of mass and dimensional formula of velocity. So here what is the formula of the velocity? Mass distance upon time. So dimensional formula of mass is only m, and the formula of velocity is mass distance upon time. So the dimensional formula of distance is L, and the dimensional formula of time 1 upon time, so it will become T inverse. So L T inverse is the dimensional formula of velocity. So overall answer is what? It will be m into L T inverse. So it will be become ml T inverse. Clear? Next is impulse. So impulse is equal to force into time. So dimensional formula of force is this one, ml t raised to the power minus 2, and the dimension formula of time is t with square bracket. So it will be force has the dimension formula this one, ml t raised to the power minus 2. Time has the dimension formula t. So just substitute in the dimension formula in the formula, you will be get the correct answer. So it will be impulse is equal to force into time. The dimension formula of force is this one, and the dimension formula of time is this one. So overall is ml t inverse. So this is the dimension formula of the impulse. Clear? Any doubt? So this is the method to derive the dimensional formulas of physical quantities like work, momentum, impulse, force, acceleration, velocity. Important dimensions of physics, or we can say important dimensional formulas, which is this one. First is pressure, kinetic energy, power, density, angular displacement, angular velocity, angular acceleration, moment of inertia, torque, angular momentum, force constant or spring constant, gravitational constant. So if we talk about the force, if we talk about the pressure, the unit is Pascal, and their dimension formula is this one, m l raised to the power minus 1 t raised to the power minus 2. Kinetic energy, the unit is joule, and their dimensional formula m l square t raised to the power minus 2. Power, unit is watt or joule per second, and dimensional formula is m l square t raised to the power minus 3. Density, unit is kilogram per meter cube, means mass upon volume. So the mass of the unit of the mass is kg, and unit of the volume is meter cube. That's why it become kilogram per meter cube. And their dimensional formula is m l raised to the power minus 3 t0. If we talk about the m, so the power is 1. This is understood. This is understood. Angular displacement, representation is theta. Unit radian. And the dimensional formula is m0 l0 t0. It means what? It means angular displacement is a dimensionless quantity. Dimensionless quantity. That's why it will be m0 l0 t0. Angular velocity, omega, unit is radian per second, and their dimension formula is m0 l0 t inverse. Angular acceleration, alpha, and unit is radian per second square, and their dimensional formula is m0 l0 t raised to the power minus 2. Moment of inertia, unit is kg meter square, and the dimension formula is ml square t0. Torque, Newton meter is the unit, and dimension formula is ml square t raised to the power minus 2. Angular momentum, denoted by capital L. Unit is joule second. And their dimensional formula is ml square t raised to the power minus 1. Force constant or spring constant. The unit is Newton per meter. Force constant, you know, Hooke's law, F is equal to minus kx. So here k is a spring constant. So it will be k is equal to F by x. So from this formula, the dimensional formula is this one, m L0 t raised to the power minus 2. Gravitational constant G. Unit is Newton meter square per kg square. And their dimensional formula m inverse L cube t raised to the power minus 2. So to represent the dimensional formula of any physical quantity, we use the square bracket only. Square bracket only. Some more important dimensional formulas of the physical quantities are this one. Intensity of gravitational field. Unit is Newton per kg. And dimension formula m0 L t raised to the power minus 2. And gravitational potential. Unit is joule per kg. And their dimensional formula m0 L square t raised to the power minus 2. Surface tension. Newton per meter or joule per meter square. So their dimension formula is m1 L0 t raised to the power minus 2. Velocity gradient. Unit is per second. And the dimension formula is m0 L0 t raised to the power minus 1. Why? Because the unit is only per second. This is independent of mass and time. It is dependent on only time. So it is independent of mass and length. Independent of mass and length. That's why here m0 L0 and dependent on time. So it will be t raised to the power minus 1. Coefficient of viscosity. Unit is kg per meter second. And the dimension formula is this one, m L inverse t inverse. Stress. Newton per meter square. Newton per meter square. And their dimension formula is m L inverse t raised to the power minus 2. Strain. The unit of strain is what? No unit. No unit. It means strain is a dimensionless quantity. Dimensionless quantity. So m0, L0 and T0. Clear? Next is modulus of elasticity. Unit is Newton per meter square. And their dimension formula is m0 L raised to the power minus 1 t raised to the power minus 2. Poisson ratio denoted by sigma. What is the unit of Poisson ratio? It is no unit. It has no unit. And the dimension formula is m0 L0 T0. Next is time period. Unit is second. So the dimension formula is m0 L0 t raised to the power 1, or we can say t. Frequency. Unit is hertz. Frequency and time period both are reciprocal to each other. So their dimension formula is m0 L0 t raised to the power minus 1. all the dimensional formula of the physical quantities are very important. Clear? Here velocity gradient Vg is the rate of change of velocity with respect to distance. Rate of change of velocity with respect to distance. Or if we talk about the formula, it will be dv upon dx, where dv is change in velocity between the two fluids, we can say, and dx is the distance between the layers. Or clear? Any doubt? Poisson ratio. Poisson ratio is the ratio of the lateral strain to the longitudinal strain in a material. The formula is lateral strain divided by longitudinal strain. Lateral strain arises due to change in diameter or original diameter, whereas longitudinal strain is change in length, or we can say original length. Change in length divided by original length, and lateral strain is change in diameter divided by original diameter. Here Poisson ratio, this one. Poisson ratio is the lateral strain and longitudinal strain. Lateral strain and divided by longitudinal strain. Longitudinal strain. Whereas lateral strain is change in diameter divided by original diameter, and longitudinal strain is change in length divided by original length. This is clear? Yes, we will learn in more detail in upcoming lectures about these physical quantities. So here our main aim to learn about the dimensional equations of the physical equations, like intensity of gravitational field, surface tension, strain, time period, frequency. Clear? Any doubt? Yes. Quantities having same dimensions. So quantities, frequency, angular frequency, angular velocity, velocity gradient, and decay constant. The dimensional formula having same. Similarly, work, internal energy, potential energy, kinetic energy having same dimensional formula. pressure, stress, Young's modulus, bulk modulus, modulus of rigidity, energy density, having same dimension formula, that is m L inverse t raised to the power minus 2. Momentum and impulse, m L t raised to the power minus 1. Acceleration due to gravity, gravitational field intensity, having same dimension formula. This helps to you to remember all that. Clear? Any doubt? Yes, you have to learn, you need to learn all these dimensions. You need to learn all these dimensions. And method, how we can derive the dimension formula, or we can say dimensional equation of any physical quantity. All right? Clear or not? Now we will learn more dimensional formula. Quantities having same dimensions. So angular momentum, Planck's constant. The dimension formula is m L square T inverse. Surface tension, surface energy, energy per unit area, m L0 T raised to the power minus 2. And now some other physical quantities like strain, refractive index, relative density, angle, solid angle, distance gradient, relative permittivity, or we can say dielectric constant, relative permeability are dimensionless quantity. So m0, L0, T0. Clear? Here, if we talk about the dimensionless, one question for you. If we talk about the dimensionless, what is the dimension formula of the physical quantity? Yes. Always remember that the dimension formula written with square bracket. With square bracket. Yes, now right. what is the dimensional formula of angle? What is the dimension formula of angle theta? Angle theta. Yes, angle is also a dimensionless quantity. Dimensionless. So it will be m0, l0, t0 with square bracket. Clear? Any doubt related to dimensional regarding to dimensional formula and dimensional equations? This is clear? Now one last question for you. What is the dimensional formula of power? Dimensional formula of power. Dimensional formula of power. Right. So to, so if we talk about the power, so first of all, here question arises, what is the dimension, what is the formula of the power? Power is equal to work upon time. Yes or no? Work upon time. Yes. And where work is what? Force into displacement. And where force is equal to what? Mass into acceleration. Where acceleration is equal to what? Velocity upon time. Where velocity is equal to what? Length upon time. So first of all, calculate the dimension formula of velocity, then dimension formula of acceleration, then dimension formula of force, then dimension formula of work, then the dimension formula of power. So this is the procedure. Clear? Dimension formula of m l square t raised to the power minus 3. Right. M l square t raised to the power minus 3. This is clear? Velocity, acceleration, force, work and power. Good. Now if you have any doubt, now you can ask. In next lecture, we will learn uh, principle of homogeneity. Principle of homogeneity. In next lecture, we will learn the principle of homogeneity. Yeah, example, if you want to derive some other dimension formula of the physical quantities, so note down: displacement, acceleration, force, refractive index, yes. Suppose we will suppose we talk about the energy, the potential energy, total energy, kinetic energy, work done, they have same dimensional formula. Same dimensional formula. Work done, potential energy, kinetic energy, total energy, mechanical energy, they have same dimensional formula. Clear? After that, we will solve NCERT exercise, exemplar questions, homework. The homework is rederive all the dimensional formula. All the dimensional formulas using the formula of the physical quantity. The limit is 10. 10 dimensional formula. 10. Clear? Thank you for your attention.